section of a cone. We all love to have cakes, and cakes do look beautiful because of the different decorations on top of it. And these decorations are made using different conical shapes. And these shapes sometimes may be of circle or it might be of parabolic. And what has this got to do with our chapter, that is conic section? So these different circles, parabolas, maybe hyperbolas or ellipses are different sections of a cone. And in this session, we will be looking at how these sections are got. That is, it can be a circle or a parabola or an ellipse or a hyperbola. So let's start with what is the basics of a cone, or what are the different characteristics inside a cone itself. So how to form a cone? So you can see that I have two lines over here, one black line named as L and another one M and another one alpha. So I have two lines in one angle alpha over here. Now what are all these? L, which is a vertical line, and M is the inclined line or the blue line, and the angle alpha, which is the angle which the line M makes with the line L. Now, if I just rotate this blue line, keeping this angle alpha, what will be the shape that I'll get here? Now, that will be quite interesting, right? Because you can even try that out. You can take a paper, you can take one line L and then another one M, and if you try to rotate it, and you might get a shape which looks like that of a cone. And here we will be discussing now about double napped right circular hollow cone. Now, what is this double napped right circular hollow cone? Now, it looks like this. Maybe in the previous diagram, you can see that this M, which if I rotate, if I keep this angle alpha fixed, it might give a shape which can look like this. So this is what we are going to discuss, or this is the cone that we are going to take. And this is not a single cone. You can see that there is a cone which is there on the upper side, as well as there is one cone which is there on the lower side. So it is a double napped right circular cone. Why this right circular cone? The angle which the base makes with the height of the cone will always be 90 degrees. So that is why we take it as a double napped right circular hollow cone. It's a hollow cone. There is nothing inside. Now, what is this double napped right circular cone and what are its characteristics, which is very important. So you have over here different, there is an axis, there is an upper nappe, there is a generator, there is an angle alpha, and there is a lower nappe. So what are all this? Axis, the fixed vertical line passing through the center of the cone. So you can see there is a vertical line L, which is also called as the axis, which we discussed before. So that is called the axis, and that is fixed. And now the generator. What is this generator? There is an inclined line. In the previous diagram, you saw a blue line. Yes. So that blue line again over here, we call that as a generator. And this generator, or the rotating line, generates the surface of the cone. So this generating line, if I rotate that generating line along the axis with an angle, I'll be getting what? The surface of the cone, right? Yes. So this line is what we call by the name generator, because it generates the surface of the cone. And now we have V, which is the vertex of the cone, that is the central point of the cone, or the vertex of the cone. And we have an upper nappe, that is the upper part of the cone, and the lower nappe, which is the lower part of the cone. So these are the different parts of a double napped right circular cone. Understood? So conic section. The definition goes like this. When a plane intersects the cone to form a conic section, you take a plane, you intersect the cone, you might get different shapes. It can be a circle or an ellipse or a hyperbola or a parabola. Now, this looks like this. That is, there is a plane, there is a blue one. That plane cuts the double napped cone and it is cutting at an angle beta. So that angle beta, what is that? The angle made by the intersecting plane with the vertical axis of the cone. And this angle beta has got a lot of importance in the upcoming slides. So don't forget about this angle beta, which is very important. So the plane here is now cutting the cone and maybe it is getting a new shape. And what are those new shapes? So the first one that we get here is circle. So when the plane cuts the nappe of the cone such that angle beta is equal to how much degree? 90 degree. So if the angle beta is 90 degree, you get a perfect circle from the cone. And the image looks like this. The plane is cutting the cone, and what is the angle beta which is formed here? 90 degree. And if this is 90 degree, that section formed from that cone will be a perfect circle. So that is about circle, how a circle is formed out from a cone. Now, how an ellipse is formed? Same way as we got a circle, we can get an ellipse also from a cone. And what is that? When the plane cuts the nappe of the cone such that angle alpha is less than beta. that is the angle which the axis is making with the generator, that is angle alpha. And if the alpha is less than beta, that is beta is the angle which the plane makes with the axis of the cone. So if alpha is less than beta and that is also less than 90 degree, you get an ellipse. And the figure looks like this. That is, there is a slight inclination for the plane. In the previous circle, you see that the plane is almost parallel, right? But here, the plane is slightly inclined. And this inclination, that is angle beta, if it follows this condition, that is alpha less than beta less than 90 degree, you get what? The shape of an ellipse. So that is how we get an ellipse. So now we have discussed how to get a circle and how to get an ellipse. Now what are the other two? We have the next one, which is parabola. How to get a parabola from a cone. So to get a parabola from a cone, make sure that the plane cuts the nape of the cone such that alpha is equal to beta, that is angle of the axis and the generator, that is alpha, and the angle made by the plane with the axis, that is beta. If these two angles are equal, you get a parabola. And how? Yeah, the image looks like this. That is, you have a plane and the angle alpha is equal to this angle which is beta, which is made by the plane with the upper nape or the lower nape of the cone. And that is how you get what? A parabolic shape. So now we have got circle, ellipse and a parabola, right? What is the last one? Hyperbola. How to get a hyperbola? The condition is this one, that is plane cuts the nape of the cone such that 0 less than or equal to beta less than alpha. So if this condition is satisfied, you get a perfect hyperbola. And how to get that hyperbola? So you see that the plane is cutting the double napped cone. You can see there is a double napped cone and the cutting is happening in the upper nape as well as in the lower nape, right? Yes. So you can see that this condition, that is 0 less than or equal to beta less than alpha, where beta is the angle made by the plane with the axis of the cone and angle alpha is the one which is made with the axis and the generator, right? And if this condition is satisfied, 0 less than or equal to beta less than alpha is satisfied by this plane, you can see that what is formed? A hyperbola is formed. So you get a hyperbola if it follows this particular condition, if the angle beta is greater than or equal to 0 but less than what? Alpha. So that is how you get a hyperbola. Now, how to get a point from a conic section? You also get a point. How to get that? You get a point if this condition is satisfied, that is alpha less than beta less than or equal to 90 degree. Remember, these conditions are very important. So in order to get a point, it has to follow, the plane has to follow this condition. Alpha should be less than beta, but it should be less than or equal to 90 degree. And the figure looks like this. That is, you have an angle, alpha and the beta, and this should be following the condition which is alpha less than beta less than or equal to 90 degree. You get the exact point that is on the center or the vertex of the double napped cone. And this is how you get a point from a conic. And now how to get a straight line or degenerated parabola. What is the straight line or the degenerated parabola? So when the plane cuts the vertex of the cone such that alpha is equal to beta. So the plane is now cutting the vertex of the parabola at what condition? Alpha is equal to beta. And how does the figure look? The figure looks like this. That is, you have two vertically opposite angles, alpha and beta over here, and they are definitely going to be equal. And if this condition is satisfied, you are going to get a straight line. And that is how you get a straight line or a degenerated parabola. Okay. And another one, you have intersecting straight line or degenerated hyperbola. What is this degenerated hyperbola? When the plane cuts the vertex of the cone such that the condition, you have to remember the condition is 0 less than or equal to beta less than alpha. And there are two conditions. It can be less than beta, 0 can be less than beta, or 0 can be equal to beta. So let's look at the first condition where 0 less than beta less than alpha. And you get two such lines. Yes. So you get two lines over here when this condition is satisfied, that is 0 less than beta less than alpha. And when 0 is equal to beta less than alpha, you get a single straight line which is the degenerated hyperbola or intersecting straight line. So these are the different conic sections. So we have discussed how we got a circle, an ellipse, parabola and hyperbola. And when we discussed about a point, then we discussed about degenerated parabola, and now last we discussed about degenerated hyperbola also, right? Now, so let's see an overview of all these things that we have discussed. You can see that you have a circle on top, okay, following the condition that we discussed, that is beta is equal to 90 degree. And then there is an ellipse, which is according to the condition, and you have a parabola, and then you have a hyperbola. So these are the four different conics that we will be discussing throughout this entire chapter: circle, ellipse, parabola, and you have hyperbola. So now, since we have discussed about the intro part of conic sections, now we have to move on to the first category or the first important conic, that is what? Circles. More about conics you will be learning in the next video. Now let's just summarize this particular session.
Manorama Horizon. Learning made simple.